In this presentation, we're going to look at conditional probability, and what we're going to do is look at a test for disease called H1N1. Now, you might notice that this video was recorded in August 2020 when COVID is going around, so you might forgive me if I accidentally say COVID instead of H1N1. So, a test to detect this virus, the H1N1 virus, shows a 5% positive rate, a positive result for those not having H1N1, and 100% positive for those who do have it. Okay, what is the probability of occurrence of H1N1 is 1 in 1,000. What is the probability of the person found to have a positive result actually has H1N1, assuming that you know nothing about their symptoms? So let's start off by actually making a statement of our notation. You should always do this at the top of the exam paper. Your solution, just state what they are. D, for me, D is having the disease. D for disease, so the D means that they actually have H1N1. T is test positive. Test result is positive. In this case, what I actually might do, I might also put up sometimes is P for positive, or T for test positive, and F for false positive. F for not having the test, a false result. You have to be a little bit sometimes. Put a bit of thought into what you're saying there. Anyway, D and T are what we're going to call our events. Okay, and what we have to do is find the probability of D given T. So they have tested positive, but what's the probability that they actually have the disease? Okay, so that's a conditional probability. So conditional prob, which is what we're doing here. So let's spell it out there. Conditional probability. So we're given the following pieces of information, and this is actually, we have to sort of run through this and set all this up in our mind. Okay, so we have the probability of D is 1 in 1,000. Okay, we're told that, but that means consequently that the probability of not having the disease is 0.999. And the false positive rate is the fact that if you do test positive but you don't actually have the disease, the probability of that is 0.05. If you do have the disease and you test positive given that you have the disease, the probability of that is 1. Okay, so now the probability of T and D can be written as follows: probability of D times the probability of T given D. Okay, that's the conditional probability formula, just reused. Okay, rearranged here. Okay, that's just conditional probability expression there. Okay, that just helps us get started, because what we have to do here is find out what the probability of T is. Okay, and we can break that up into two. The probability of T is the probability of a positive test. Okay, and you could test positive and actually have the disease, or you could test positive and not actually have the disease. Okay, so we actually have that already, the probability of T and D, but also what we have to find out is the probability of T and not D. Okay, so that's the probability of not having D times the probability of testing positive given that you don't have the disease. T given not D. Okay, so that is 0.01 from this side here, this expression here, plus the 0.999 times 0.05. Okay, and working that out, a little bit of calculator work, we should get 0.05095. You can round that up if you want. A key skill here really is just being able to decompose probabilities like that into two component terms. Okay, so you either, if you have tested positive, you either do have the disease or you don't, and there's nothing else. There's no other possibilities. Between the two cases here, we have 100% of all the positive tests. Okay, it's what we say, it's exhaustive. Okay, so we can do that. So that's the key trick really with these conditional probability questions, is sort of knowing how to express it out like that, because after that really what we're just doing is just re-employing the conditional probability formula just to simplify things. Okay, that's that step there from here to here is just really reworking the conditional probability formula, which hopefully you should know before you attempt these questions. Actually, I have it down here as well. So this is the question we're asked. Find the probability of t given d, and that's the probability of t and d, or intersection d, divided by the probability of t. Okay, so we figured that one out pretty quickly. Probability of t and d, and the probability of t on its own is 0.05095. So 0.001 divided by 0.05095, that gives us an answer there of 0.01963. You probably don't have to be go to as many decimal places as I did there, but so 3 or 4 is usually enough. Okay. I just had it written down, so I didn't bother changing it. Okay, we'll leave it there.